When we founded RIASA, much of our work was already grounded in systems thinking. We were supporting organizations in the social sector and in market systems to design strategies, programs, and intervention in complex environments. And I have to say that systems thinking proved extremely valuable. It helped us map actors, understand relationships, identify feedback loops, and recognize where influence and power sit within the system. However, as our work evolved, we began encountering a recurring limitation. Systems thinking helps us understand how systems function today. But many of the strategic questions organizations were asking us were really about the future. For example, how do we design strategies for systems that are constantly shifting? Or how do we intervene today in ways that remain relevant 5 or 10 years from now? Or how do we anticipate structural changes that may reshape the systems itself? This led us to an important realization that understanding how system works today is only part of the challenge. Systems are constantly evolving, so if we want to shape outcomes, we also need to think about how those systems might change over time. This is especially true in complex adaptive systems where the future is not simply an extension of the present. Systems evolve as people respond to incentives, as policies shift, as new technologies emerge, and as social and economic conditions also keep on changing. It also means that organizations rarely operate in isolated systems. They are usually part of systems that sit within larger systems, what we sometimes call meta systems. And for example, a civil society organization working on health policy is not only operating within health system, its work is also influenced by political dynamics, by economic conditions, funding, environment, and global development agendas. And because of this, shaping the future requires more than understanding how systems behave today. It also requires exploring how those systems may evolve. And this is where foresight becomes essential. Over time, we began then integrating these two approaches in our work, and that integration eventually became the foundation of the methodology we now call Systems Informed Foresight. So to talk a little bit about how we integrated it, we began by looking more closely at two fields that are often used separately, but that can actually complement each other very well. The first is systems thinking. As I said, it helps us understand how a system functions today, how different actors interact, and how certain patterns emerge. And the second one is the foresight. Foresight focuses on how the forces shaping a system may evolve over time. It helps us identify early signals of change, examine structural shift, and explore plausible future scenarios. So what we began to realize through our work is that these two perspectives naturally belong together. Systems thinking helps us understand the current dynamics of a system, while foresight helps us explore those dynamics and how they might change in the future. And when you combine the two, you can test your strategies against different possible features before committing to a particular course of action. This integration is what we call systems informed foresight. It literally brings together systems understanding and future exploration, helping organizations design strategies that are grounded in present realities while remaining responsive to emerging changes. Now, let me talk about the core idea behind SIF. At its core, SIF is built on a simple idea. If organizations want to act effectively in complex environment, they need two things: a clear understanding of the system they operate in, and an appreciation of how that system may evolve in the future. SIF brings these two perspectives together in a single approach to decision making. It starts by framing the problem and understanding the structure and dynamics of the system. From there, it explores how that system might evolve under different conditions. In practice, what that means is identifying leverage point within a system and using them to explore how different drivers of change might reshape the system over time and how interventions may perform across alternative futures. So in a sense, SIF connects systems insight, future exploration, and practical action. And to operationalize this idea, the methodology is structured around a continuous learning cycle consisting of 3 stages: awareness, application, and adaptation, as mentioned earlier on. The first phase is awareness. This phase focuses on understanding how a problem or a strategic question is situated within a wider system. Here, what we do is we begin by framing the problem or question and situating it within the system of which it is part of, while also defining the boundaries of that system. Then comes the systems diagnosis, where we examine actors within the system, how they relate to one another, looking at power dynamics, what incentives shape behavior, and how institutional arrangement or narratives influence outcomes. Through this process, we begin to map the systems and identify leverage points where change may be possible. For example, if we look at the challenge of low childhood vaccination rates in the health system, in the awareness phase, the issue is not framed simply as a technical problem or insufficient vaccines. Instead, the problem is situated within the broader health systems. This may include examining the roles of national health authorities, roles of local clinics, community health workers, international donors, and community leaders. The system diagnosis then look at how those actors interact one another. For instance, supply chain delay affecting vaccine availability, or funding mechanism influencing how resources are distributed, and community beliefs or misinformation influencing how caregivers bring children for vaccinations. We may also have power dynamics between policymakers and local health providers, affecting health services delivery, which in turn then affects health outcomes. So when you begin to map this relationship, it helps you see where meaningful influence exists within the system. Once this understanding is developed, then we move to the second phase, application. This phase translates systems insight into practical action. So if the first phase focuses on diagnosing and mapping the system and identifying leverage points, the second phase focuses on using those leverage points to design intervention strategies. At this stage, foresight becomes particularly important because this is where we explore how the forces shaping the system may evolve and how potential interventions may perform under different future scenarios. And this may involve designing interventions. It also may involve developing pilot initiatives or experimenting with new approaches. The goal here is to ensure that actions are grounded both in systems understanding and in plausible future development. If we have to use the vaccination example that I gave earlier on, imagine that our system analysis shows that community trust and reliable vaccine supply are 2 key leverage points for improving vaccination uptake. In this phase, the application, we will start testing practical ways of acting on those leverage points. For example, this may involve strengthening community health worker network or even building partnership with local leaders to help address misinformation and build trust around vaccine. At the same time, we may also explore how future factors such as population growth or changing funding environment, like recently, could influence how this intervention performs over time. And what possible future scenario we can also consider to ensure that they remain effective and sustainable. The third phase of the SIF cycle is adaptation. Why adaptation? Because complex systems are constantly evolving. As I said, as organizations act within a system, the system also responds. So sometimes those responses are expected, but sometimes they create unintended consequences. The adaptation phase focuses on learning from those dynamics now. At this stage, we may pay attention to signals emerging in the system, reflecting on what is happening and how, or maybe adjust our strategies as conditions also evolve. So let's return to the health system example. In the awareness phase, the system is mapped and key leverage points are identified. They are identified. In the application phase, an intervention is introduced, for example, an effort to improve collaboration between different actors in the health system. As the intervention unfolds now, practitioners observe how the systems respond. Some changes happen as expected, while other changes reveal new barriers or behavior that were not anticipated as we were designing the intervention. And this is where adaptation becomes particularly important. At this stage, collaboration between practitioners and researchers become very valuable because practitioners, they bring practical insight from working with the system, while researchers can analyze these dynamics more systematically and help explain why certain patterns are emerging. At the same time, these observations can also be treated as signals of possible future change. So when you interpret these signals, then you can update your scenario or multiple scenarios that you come up with and rethink how strategies might need to evolve. In this way, adaptation phase turns implementation into a continuous learning process, connecting practice, research, and future thinking. Together now, awareness, application, and adaptation form an ongoing learning cycle that helps organizations move from understanding to action, while also staying responsive to how the system continues to change. Now, let me talk about